Hey there, welcome back to the channel. So in the previous video, we were debugging some stuff, and that's what we are going to continue today. So what is happening is that in my executable, I have a block which is of size 4072, and I have added a plus one to it, which is 4073 to denote tell that it's an allocated block because all of my blocks are aligned with 8 bytes, so they are multiples of 8. So if a block is found to be odd number, because they are aligned to 8, so definitely all of them are even. So if a block is found to be odd number, so that will say that then we can say that it's an allocated block. So but what's happening is that it is a free block, but sorry, it is an allocated block, but it still has the value of an even number. So because of that happening, our pointer arithmetic is like messing up. So we have to check like who is modifying at that address. So I'm going to use watch point set expressions at that specific memory address. So that's what we are going to try today. So let's just get started. Sorry. So I'll first set a breakpoint at main. I guess we have to run to set up developer tools access. What? Okay. Yeah. Okay. So yeah, we stopped at main. That's fine. So let's just get started. So now we have to set up watch points. So watch points set expressions. So let me tell you at what code do we have to set. So first I'll set another breakpoint. It will be at breakpoint, let's say allocator.c. The line number is specifically like when we are allocating the block. So let's set it at a few locations, let's say at 212, my bad, sorry. Yeah, let's set it at 211, at 252. These are at, I have already written them down. This is what I was trying yesterday. So, yeah, let's continue. So we should, yeah, okay. So if I do flip variable, this is the first block that is to be allocated. Oh, my bad, I did not run this using yeah, short traces in this. Yeah, now this should work. Yeah, main, and then if you continue, and if I do frame variable, this is 2040. Perfect. So if I do this again, sorry, if I do this again, it's still 2040 because, yeah, that's fine. And now it should be 48. Yeah, perfect. 960 is left. Allocated HS. As you can see, the allocated header size, which is allocated HS, is 49, which is one more than the total, like the appropriate size, because it denotes that the block is allocated. The same goes over here. New header size and new footer size. These are allocated. So we have given the process what they asked for, which is 2040, but just added plus one to the size. We did not give it an extra byte. The total space is still 2040, but we just added you can say plus one to the size values on in the header and footer. So if I do frame variable, I don't need to, I actually know where I have to keep a look at, and this is the position. So let's say frame select, yeah, I'm over here. And now I will add a watch point at, let's say, watch point set expressions. I'm not sure if this works, but I guess this is dash W, right. So I only have to look at like write things. Let's also look at read and write. How about that? Right? Yeah, let's do it. Read and write, and the address is this one. Is it done? Size 8, enable type RW, read and write. Yeah, I think it's done. New value is 2041. Yeah, 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 sure, sure, sure. So now I will So br list, yeah, these many we don't need to keep a track of them. So br breakpoint delete should do it. Yes. If I do br list, yeah, sure. So continue. Yeah, we will stop over here. And why is that? Because this was modified. This was red, right? Yeah, the free block. Yeah, right. Free variable pointer current this. So block size is 4073. That is correct. This is what it should be. Indeed, I should have set it like only right stuff, right? Yeah, it's fine. You know, let's free variable, the same thing. The actual size. Ooh, this is garbage. Yeah, this is garbage because we haven't reached that position yet. Like this statement hasn't been executed. So new block size is, if I do n, now we should get a good value. Yeah, the actual size is 2040. Yeah, sure. Oh, why did I copy that? But okay. So 2040, that's cool. Continue. Main variable, new block size was modified over here and here. Actual size, VHS, VHS, N. Main variable, yep, 2040. That's cool. VHS, which it should be. So continue. Main variable, it was passed um, over here, so left block was red. Yeah, how about we quit this and we only set for right because that's what we really wanted. Let's not look at like read things, right? So LLDB and driver, we'll set a breakpoint for main and then we run, we reach over there, and now we have to set a watch point, look, allocator.c 211, 252, and 266, and we continue, reach over here, if I do this, and we have the new value, so the new block. Now we can remove all the PR delete, yes, watch point, set expressions, at the address of dash W, only white. And then we set it at the address this, boom, new value is 17, so that's cool, size 16, new value is 17. Oh, I forgot. We have to use the runner short trace as well. Oh, because it had like a different address. Yeah, sure. Yeah, let's put that again. So LLDB and driver, big point main, run, big point allocator dot c 211, 252, 266. So three big points. Whichever runs first, it's fine for us. And then we continue, reduce the position. I forgot again, didn't I? You know, br delete, yes, run dash f short trace, big point main, big point main. beyond list, and then we run dash of short traces. Yes, then we get b allocator dot c 211, 252, and 266. Nice. So now we continue, and then we reach that position. New variable, new address, which is the appropriate one. Watch point set expressions dash w only for write, and the address that we want to look at. New value is 2041, and now we'll remove every breakpoint because we don't need it anymore. Yeah, and then we continue. Okay, so someone modified this over here. This, okay. So this is my free, and this is new block. This is after the block. So this is the else condition where we did not find any appropriate blocks in the left or the right, and we are just changing the current allocated block to a free one. So this should have, yeah, 2040. Not this one. We should look at this. So new block size. Yeah, let's over here. Okay. Yeah. Now we should get a good view. So free HS will be 2040. That's perfect. If I do next, what happens? Just yeah, it's gone. So okay, continue. So left block size is total new size. Okay, so we are trying to coalesce L. The pointer is at this. So frame variable left block size is now left total new size. So left block size, where is it? Where is it? There is a variable left block over there. Okay. So what is total new size? Total new size is 2120, which is because of 2040 plus 48 plus 32. Is that correct? 2040 plus 48 plus 32, 0, 1, 8, 12, 2120. Yeah, perfect. Got it. Continue. When variable is now 216. Continue. When variable total new size again, the same thing. It's this. Continue. When variable allocated header size. This. This. So what is align size? Align size is at this position 2040, and this will become 2041. So that's fine. That's fine. That's fine. That's fine. Continue flag variable. Again, this was modified in variable free HS is 2040. So that's fine. Yeah. So continue in variable left block size is now total new size, which is 2120. That's fine. It is under coalescing and yeah, sure. Continue variable. Again, total new size is 6224, which is correct. It's going to be a problem when we find one which is odd. I think that's what the main thing is. So okay. So continue field variable Line size is 4072 and we are storing 4073. That's correct. So continue variable next, next, main variable 4072. Yeah, okay, so free header size is 407. That's correct. So continue field size, then variable header size or one. So let's move to the next statement. So CHS is 4073. This is inside my malloc, and to denote that we have allocated it, we have plus one. So this is correct. If I do one was this 4072. So this is correct. Same because we keep the same block. So what happens here is that we ask my malloc for uh, space, and then it searches inside the free list. We do find appropriate free block, but it's not like super big that we can split it. We will just allocate like this is the you can say this is the best fit. Hence, we do not split the block. We just give that entire block to the process. So we just set the values to 4073. Just increase one. That's fine. That's correct actually. So this is all fun. Yeah. Okay. So this is correct. So continue for variable n and variable VHS is 4072. Yeah, okay. Continue. So in variable total new size is 8176. Yeah, okay, correct. What is in N? Yeah, correct, correct. That's correct. Over here. So okay. Continue in variable align size. So what is align size? 2040. And then we set allocated header size as 2041. Sorry. Yeah, okay, perfect. Keep going down, down, down. Get this 2041. New header align size plus one. 4073, that's correct. This is correct again. Yep, correct again. It's inside my malloc. We allocate this as odd. Continue for variable. So this is my free. We allocate the free header. This it has new block size. It's 4072. So that's correct. Okay. Okie dokie. Same matches as 4073. So that's correct. actual size was found to be 4072, and for the free block, we just decrease this. So that's correct. Mhm. Mhm. And then we are stuck over here. I really believe there's 1007, which is 4000 and something. So if you go up, the block size was found to be 4071, which should be 4072. It's a coalescing R, and the heap high value was this 1007, and the right block was found at 107 itself. This should actually not be allowed. So the block was this. Its block size was found to be 4071. Last time we checked, the only person that modified this was this. Actually says this, DHS, which is new block size. So the new block starts from this, and free header size and footer size were set to 4072, which is correct. Block size. Sorry, but nobody really modified it. So what happened? My flea was the last to modify it. Wait, let me check how to set it. NMDB watch point expression on address. So as this, so the watch will be given by location. This option you can set the number of bytes to watch with size. So set the watch point on the variable. Execute the following code, set a breakpoint at the second line. Watch point set expression this, watch point one hit. Yeah, why aren't we getting this? Uh, what is happening? 26 minutes in and we haven't done anything. Oh boy, who is changing this value 40? Uh, uh, we are stuck at the same thing. 4071. What's happening? What are you doing? Why is it 4071? I don't get it. Oh my god. 4071. So last time we checked, it was freed, like the address, new block, the next week, but inside my free. So we are over here. So the new block this. Okay, well, it hasn't been executed yet, so we can't really judge. New block is equal to free pointer is equal to next new block. I still don't get it. Wow, what is happening? Also, 7.1. The last process that tried to modify this was this one. Why am I not getting like the so new block size was modified over here and it became just free header size. Sorry. So this is free header size. It became 4072, 4072. This is free. Then why is a free block inside this over here? Why are we tying to free? an already free block. So the pointer we got was this C430. Uh, okay. No, no, sorry, this is the main thing. So this is 18. 18 is 24. So we are trying to free an already free block. Why are we doing this? This is already a free block. Oh my God. So here we are trying to free an already free block. That is what is happening. How did it reach over here? You get this? Why are we doing this? Hmm. Why are we? Why did the person try to free an already free block? Well, not person, but the code did. But did I mess up somewhere? But it's called by M driver. We don't have any authority over that, right? Sorry. Yeah, let's quit this, and I'm going to add a statement. Let's not quit this, but I will add a statement over here. So exercise minus one. So here we add if new block size mod 2 is equal to 0, but it's already 0. Printf stop bro, why you trying to create an already free block? I didn't have any other print statements, right? Yeah. So this should work mostly. Just return 0 over here. Not return. Let's do this. Exit. Exit with a 1. Yeah. Let's try this. So this is saved. So make an M driver dash short traces. Yep, we got that. So we block of size this. We are trying to free an already free block. Is that because of the heap high and heap low checks? That might be it. Sorry. So it tries to merge that and it already finds this. Yeah, let's do one thing. How about sorry. So printf let's go. So let's see, what do we see? Yeah, we see a lot of statements. So this is there's like simply repeating that stuff, or there is a frequency to it, right? So this, yeah, this is one thing, and this is the repetition of it again. Sorry, 48, 4072, 4073, 31, 49 is this, yeah, 48, 49, 207, 233, 001, 2321, 233, 001, 2321, 233, 001, 2321, 233, 001, 2321. Yep, this was supposed to be 1, but it wasn't. 2321. This was supposed to be 1. So something messed up over here, basically. Free this becomes this. Wait, what? Okay. No free list, no free list, no free list, no free list. Null, null, null. Yeah, this should be at the end. Sorry. Okay. So, yep, allocate this 2040 free. After free, we have 2040, this. After free, we have it, so this, after free, this, sorry, after free 4073, this is the big one, and now it's back again. Since we had that much space while coalescing, just use that space. Okay, cool, bro. So, blocks are empty now. So it tries to allocate 2040. It tries to allocate 2040 again. 32041 becomes this. Let me draw that. Where should I draw this? Let me just think of it. So I don't need this right now. Yeah, I have a image of it, and this is just so none of okay. 41 minutes in, no one is going to watch this. But if you're watching this, hey, thanks for watching. But I would highly recommend you to not watch any further content in this video, not any of my videos, but just in the further videos because it's mostly just me debugging and scratching my head. So it would be better if you like do some other stuff, some other productive stuff. Maybe work on your own project, you know, uh, something that you have in your mind or something else. But yeah, thanks for watching this video. Bye. So I I do know most of the stuff. Yeah, okay. So I'll remove this. I know most of the stuff over here. Step into, yeah, continue, yeah, print variable name, string variable, string select, backtrace, string select, watch point set variable, w read. Yep, now I know. Kill is for kill purposes. Yeah, yeah, sure. So we have an empty block. I think I know why this is happening. I think it's mostly because whenever we um whenever we free a block, it should be like completely zeroed out. That's what I have. That's what I think is happening. Hmm. Okay. So I have some things in my mind, but okay, let's keep going. So this is one entire block. So 2040 2040. This was read and this was wait. So this is a 12,000 block. We allocate 2040 from it. It becomes 10,000. Then 2040 again. Yeah. 5,000. This is a free block. Was it because of then heap? So inside free, whenever we are inside free, I also need if that was free using R and or something else. Yeah. Okay. Let's do it. Let's do it. Let's do it. Hmm. Interparallel. and then the new line, oh no, only R. Yep, printf L, new line, printf RL, new line. Now we have a better view, you can see. Slightly better view, but not much. So this all works, this is fine. So we reach over here, somewhere over here. RL 4073, it becomes 12,000, yeah. So this is the last block that was freed. It becomes 12,320. Then we allocate a block again, and free gives us this. So free 2040 There is no block, so it did not find any blocks in the left and right. Hmm. That is strange because it should find 8176 beside it. Why did it not find that? 8176. It's a free block. Why did it not find the sun is shining? So let's say we are inside left block free and right block free. Oh, my bad, I missed it. So left block free, enter left block size, then enter right block size, this is fine. 2041. So when we try to reach 2041, on the right we found wait, not this. Yeah, yeah, yeah. So allocating 2040, allocating this. When we try to free this, we found a block on the left side. Is this left? Why didn't we get anything on the right? Is it because of memory block? Okay, okay, okay. Left is this, R is nothing. What? What is happening? Why the L? Why the L? Why the L? Yeah, because of left merge. Yeah, yeah, sure, sure, sure. Yeah, okay. We were over here, so 12,000. Yeah, we found left something. We did not found anything at right because we returned that before that because of mem heap high, which is technically correct. Um, Wait, so mem heap high is being reset. Okay, so okay, this is getting tiring. So what I have in my mind right now is uh after yeah, okay, okay. So this is the last thing. If I'm able to confirm this, that means I know why this is happening, kind of. Not the entire reason, but just a small one. We want us to efficiently manage the memory, so we do this. So heap low is boom, 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 boom. Then heap low is at this, and the mem heap high at that position, and we are trying to. They don't get a rightfully blocked. Yeah, yeah, yeah. So rightfully blocked, we aren't getting anything. I think it is because of this statement. So printf. How about we do this before calling? Uh, yeah, so inside what we'll see. Left was called, and then we do this. So printf. So I know heap low. I'm not sure about heap high. Yeah. So heap high is this, not this. Sorry. So this is yeah. This is going to mess up some stuff. No. What was it called? mem heap high. Let's see. It's going to do some damage. Yeah, okay. Heap low. Okay. So heap low is set at. So this is uh, the the init one. So this is initialized at this, which is the same position as this one because it stays the same. As you can see, heap high has changed. It is now 14.7 FFF. Heap high stays the same for continuous Y. So the last time we checked heap high, the maximum value of heap high was is this one, right? 303F. Yeah, let's convert that. Let's convert this to decimal. This is definitely lower than that, but by how much we are not sure. So 1 byte lower than this. Heap high doesn't change at all. Hmm. Because we don't call mem as VRK anymore. It's not changing the stuff. I think I know it. So when the first iteration completes, so what's happening is that it's doing 10 iterations to find like it's a formula, so they take some kind of average. So it's doing 10 iterations of our program. So what happens is that in the first iteration it does everything correctly, and in the next iteration it does not our memory is already allocated and we are not giving it back to the OS, you can say. So how is it supposed to reduce? What is the opposite of mem is PRK? Let's look at those. Look at that function. Let's do it. So we have these functions here. Mem is PRK expands the memory by increment bytes. Increment is a positive non-zero and it is generate point with the except that is zero six possible. Yeah, yeah. First byte memory, heap size, current size of heap bytes returns this. Yeah. So what's happening is that the heap is already the space that is essential is already allocated. So it doesn't have uh, anything to what you can say. So I need to keep track of the heap high, the current heap high. Because I've added the statements of heap high and heap low conditions to like avoid uh, trying to access memory out of our expected heap, you can say, I have to change that condition. I cannot rely on that because of the implementation by the guys. So what's happening is that, yeah, I think I get it. So what's happening is that whenever, let's say, so over here, let's say, so this is the first iteration. So this is the first iteration from here to here. So this is the first iteration. This is the second iteration. So what happens in the first iteration is that The final block, when everything was allocated and everything was freed, we are left with one huge block of size 12,320 bytes. But then what happens is that this does not disappear. It stays. Free pointer should again become null. Is that what I'm saying? Somehow this needs to be freed. Somehow. How do we do this? How do we do this? How do we do this? How do 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 do. Sorry. So this block is created, one huge block. Then we want to allocate 2040. Since the free pointer does not change, it's pointing to this block, and it should indeed point to that block. So nothing wrong in that. Just give me a minute. Hey there, I'm back. So, uh, how are we going to do this? So, if you don't understand, so we are left with one huge block. But since we are never going to call Memels Vyakya again, so as you can see, like after every iteration, the heap low is modified to you can say the base position again. Heap high is pointing to this because it was a reset by the um. So do they expect us to also do the same thing? Is that what they are saying? Should we also free it up? Yeah, I'm not sure. What are the function given to us? Heap high, hip size. Yeah, okay. I cannot rely on heap size then. Heap high then. So what they are doing is that they are resetting the heap high value to like the 1 byte less than this. But because of that, our our free list is still there. It's not gone anywhere. It's still present over there. So if you do free pointer null, Then we will call minus VRKKN. So if we are able to do, if you are able to reset free pointer variable after every iteration to null again, then this will work. How to do it? That is the question. Hmm. Hmm. Somehow I need to do it, but how? Or I should change the heap high and heap low logic. But even if I do that, the variables will still stay the same. I still have to rely on the current iteration. I think I get why this is not working. So I have a realization like, oh, how to get it working, but I'm not sure which is the yeah. They as I expect heap high never changes the value except this, which is this one 2040. Yeah, look at this. Yeah, this is when it changed the changes. But look at this fragmentation. This is bad, very bad, bad. Okay, how are we going to do this? So after every iteration, okay, let me do this. So RG10, if I do this, yeah, a lot of stuff. Sorry, yeah, I shouldn't have done this. What was it? Eval. Yeah, something related to eval. RG10, this. That's what I look. Yeah. No. I mean this. 10, boom, boom. Nah, bro. RG, boom, boom. Is it this? Then this. Is it? Oh, sorry. My bad. This should be before this advance. Yeah. So this is the 10 iteration. So this is the function that's doing the so get dot. This is the function f6 dot c. So then get dot timeout get duty f10 get duty f10 get duty. Yeah, this is the function. The f function where is it coming from? Who's calling this function? M driver is calling this function. With eval libc speed. Ah, let's get into it. What is free trace function? Yeah, okay, let's end the video right now. There's no point in sitting here trying to debug stuff because my head isn't working right now. This was a not so great video, but that's fine. You know, some days are good, some days are bad. That's fine. But the main thing is that we keep working on it. So I guess that is it. So I'm Ananta Pachorne, and I'm an engineer for fun. Bye.